Today we're starting our sections on trigonometry. So what trig helps us with is it can help us find unknown side lengths in triangles, and it can help us find these angles if we don't know what they are. So first I'm going to talk about this down here, and then I'll tell you what this SOHCAHTOA means. So the three trig ratios are sine, cosine, and tangent. And the way they work is you always do the sine, cosine, and tangent. They all go with an angle. So sine of an angle, cosine of an angle, tangent of an angle. And what that equals is the ratio of their side lengths. So all of these fractions over here are sides. So everything down there on the fractions is sides. So the sine of an angle is equal to the ratio of the opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And the tangent of an angle equals the ratio of the opposite side to the adjacent side. So now we have to decide how we come up with these opposite, adjacent, and hypotenuses. So over here I wrote out, we're going to find the sine, cosine, and tangent of angle A. So that's what we call our reference angle, because we're talking about angle A right there. Okay, the hypotenuse is always the leg opposite the right angle, or excuse me, always the side opposite the right angle. The right angle box kind of points at it. So this length here, C, is our hypotenuse. The leg that's all the way across the triangle from the angle that you're talking about, so our reference angle here, this one is your opposite. And the side that's touching it is your adjacent. Okay, so across is opposite, touching is adjacent, hypotenuse is always hypotenuse. So the way you write out the trig ratio for the sine of angle A, it's the opposite side, so opposite, over the hypotenuse, which we have as letter C. Cosine of angle A, we just use this ratio right here, is the adjacent side, which is a B, over the hypotenuse, which is still C. And the last one, the tangent of angle A, is the opposite side over the adjacent side. Okay, so that's how you write out those ratios. So the reason this says SOHCAHTOA is because it's just a little acronym that helps me remember which legs go with which trig function. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's all of these things just abbreviated. Just again, the one thing to remember is the sine, cosine, and tangent, those are always attached to angle measures. The ratios are the side lengths. Another thing when you're writing out a triangle, when we solve these and get more in depth, most of the time they'll be triangle ABC. The angles are always capital letters, and then the side that's across from it is a matching of that lowercase letter. So if this is capital angle A, all the way across the triangle, we write a little a for that side. This, I know it's hard to tell, but this is a capital C. All the way across the triangle is a little c, then capital angle B is across from side lowercase b, is how that works. Okay. Oh, also you should already have these copied down, so make sure you have your notes copied down before you start watching this video. Okay, so for our first example, it says, oh, another thing is the abbreviations like this, they are still pronounced sine, cosine, and tangent, not sin, cos, and tan. So for this first one, we're going to find sine, cosine, and tangent J, so of angle J. But then we also have to find the sine, cosine, and tangent of angle K. So I like to draw out two separate triangles so that I can pay attention to what my reference angles are. So on this first one, if I'm finding sine, cosine, and tangent of angle J, that means this is our reference. Which means, see if you can label these sides. Which one's opposite, which one's adjacent, and which one's the hypotenuse. Across from the right angle is the hypotenuse. All the way across the triangle is opposite. And then the side that's touching angle J is your adjacent. Okay, so now we're going to do the SOHCAHTOA. Sine is opposite over hypotenuse, that's the SOH. Sine is the opposite over the hypotenuse. Cosine of angle J is going to be, so A, so the adjacent over the hypotenuse. And the tangent of angle J is opposite over adjacent. And we're just going to leave them as simplified fractions like this. I don't want you to answer them as a decimal. You just leave the ratio like this. Okay, so the reason I draw out two triangles is because now we're going to do it again, but this time our reference angle changes. This time we're talking about angle K. So that might not think like a whole lot goes on, but it does change our values. 13 is still the hypotenuse, but our opposites and our adjacents change. So all the way across, now 12 is our opposite length, and 5 is the adjacent length. Okay, so now we're going to do the SOHCAHTOA part. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is the opposite over the adjacent. Just leave it as 12/5. Don't write a decimal. Okay, we're going to leave improper fractions there. Okay, so now we're going to use what we know about special right triangles to find the sine, cosine, and tangent of 30 degrees. So specific values here. So here's our reference angle, 30 degrees. And remember, we talked about it on Monday and Tuesday. I know these have X's in them, and when we did the last notes, they were boxes, but it's the same idea. The side that's across 30 is the X by itself. The hypotenuse is twice as big as the X by itself. And then the side that would be opposite 60, because there's 180 degrees in a triangle, would be that value times the square root of 3. Now, what's cool about trig ratios and just trig in general, triangles have the same ratio of side lengths. So it doesn't matter if this length was 14 or 24. This ratio of values is going to be the same. So it doesn't even really matter what that X is. So if I fill out what we know, let's do the list out the adjacent, the opposite, and the hypotenuse. So write those in. So all the way across, here's our opposite. Across from the right angles are hypotenuse. And the other side that's touching, that's our adjacent. So you always do, sine goes with the angle measure. So sine of 30 degrees sine of 30 degrees is the opposite, so x, over the hypotenuse, 2x. Well, we can simplify that. If you have the same thing on top and bottom, they cancel. As a reminder, though, this is 1 times x. So when you cancel those, sine of 30 degrees is just 1/2. And if you type in your calculator sine 30 and you're in degree mode, you will get 0.5. Okay? So now let's figure out what cosine is. Cosine of 30 degrees is going to be the adjacent, so x root 3 over the hypotenuse. So again, just like I said before, these ratios work for all triangles. So those x's they cancel out. So cosine of 30 degrees is root 3 over 2. So the last one, see if you can start that one off. So tangent is opposite over adjacent. Okay, so very similar to the one up here. Remember, that's a 1 times x. So that when you cancel out the x's, you get 1 over the square root of 3. Just like we did in the special right triangles, you cannot have a square root on the denominator. So we rationalize it by multiplying by root 3 over root 3. So when we go straight across here, 1 times root 3 is root 3. Root 3 times root 3 is 3. Okay, if I'm ever going too fast, remember you can always pause this. Okay, last one. So now we need to find that missing values on triangles. Okay, so our reference angle here is 20 degrees. So let's fill out our lengths, the opposite, adjacent, and hypotenuse. Okay, so we are going to use sine, cosine, and tangent to help us solve for x and y here. So with what we have here with 20 degrees as our reference angle, let's say I want to solve for x first. So that means I'm looking for opposite, and they gave me the hypotenuse. So I'm looking for opposite, I have the h, which of these has an O and an H in it? That's the only one. So that means to get x, I know I need to use the sine function. So sine of 20 degrees, because that's our angle, equals the opposite over the hypotenuse. Now, sine 20 is just a number in your calculator. So you should be able to see on your calculator, I told you to get one like this that has sine, cosine, and tangent buttons. So sine 20 is just a decimal in your calculator that you can get. You need to make sure that you get the same thing as me. So if you type in, like right now, just to check, if you type in sine 30 and it doesn't say 0.5, you need to change the mode on your calculator. And if you can't figure that out, I'll help you when I get back. Okay, so just so that we don't round until the very end, we have sine 20 equals x divided by 14. So to get x by itself, I'm just going to multiply both sides by 14. And again, that's just a button in your calculator. So I'm just going 14 times sine of 20, and the x value, let's see, round to the nearest hundred, is 4.79. Okay, so we've got x. Now we've got to get y. Sorry, that really didn't write very well. Okay, so if we want to get y, that means we're looking for adjacent, and again, they gave us hypotenuse. So which trig function has the A and the H letter? That one. So we can say we're using cosine then, because we have adjacent, or we're looking for adjacent and we have hypotenuse. So the cosine of 20 degrees equals the adjacent over the hypotenuse. So over here on the right, we have y divided by 14. So to get y by itself, I would just multiply by 14. And again, this is just a button in your calculator. It's just a value that you can figure out. So I'm going to do 14 times cosine of 20 degrees. So that length is about 13.16. So your homework is page 537, 1 through 15 all. If you have any questions, I will be here before and after school tomorrow. The book page is right there on that top folder in Schoology. You can email me if you have any major questions.